In part C of this experiment, we want you to create a myopic eye and work out the correction needed for it. We build our eye this way. We get a 10 diopter lens, put it in the lens holder, and position it exactly one focal length from this screen here. Now this represents our eye. The 10 diopter lens here stands in for our cornea and lens. The screen here stands in for our retina. And because the lens is at exactly its focal length from the screen, any parallel light coming into this lens will focus sharply there. And we can confirm that by putting up the mirror, and just we get a nice sharp reflection. Now a myopic eye has a mismatch between the power of the lens and the length of the eye, and in particular an axially myopic eye is mismatched by having an eye that is too long. So what we want you to do is move this lens 2 or 3 centimeters to the left, okay, and now it's axially myopic, and if we put the mirror up, we no longer get a clear reflection there. Okay, so what sort of correction do we need for the myopic eye, for the short-sighted eye? We can find this out by putting an image screen here. In this case, we're actually pretending that the image screen is the object, and we move the image screen around until we get a nice sharp picture of the crosshairs there. This point here is the furthest away that an object can be and be focused by this eye. This distance here, from here to here, is about -1/2 of a meter, which means that the divergence of light coming from here into the eye and being focused is about -2 diopters. That means that the correction for this myopic eye is -2 diopters. So I'll take a -2 diopter lens from the trial case. It's here. And I can hold this in front of the eye, and that has corrected the eye's myopia. We can check that the myopia is corrected by putting the mirror in front, and we get a nice sharp reflection now. So now this combination of 10 diopter lens and -2 diopter correction exactly matches the length of the eye.